Hi, everybody. So we will start that BoF session on sample classification. So the question that we want to discuss today is whether we need an interdisciplinary classification vocabulary for sample types. You have the agenda here on the slides. So I will give a short introduction to what is the problem that we want to address. And then we have 3 presentations on samples and related, say, topics. And then we will basically go into the discussion. And you have in the QR code at the bottom the link to the collaborative notes. So it would be nice if you say, go to the notes and subscribe to that. Could you go to the next presentation? Okay. Go to the next slide. So we will talk about samples. That means objects that has been subject to a measurement. So in the science, raw data is often collected from a measurement investing some physical object that is a sample. And when we do such measurements, well, often, maybe not always, but often, so the information about the measurement technique and the parameters of the measurement can be captured automatically. But the sample that is subject to the measurement, well, is in general not captured automatically. And that is the reason why we often lack proper information about the sample in the data set that we produce. And we also lack a very standardized schema to describe those samples. And yeah, as a result, in the data sets, we are missing that essential piece of information. And without that, if we only have recorded the how of the measurement, but not the what, then the raw data set is basically useless. And that is definitely then not fair. And therefore, we need to address that problem. So what we essentially need is better sample descriptions. But this is something that is far from trivial to achieve. Next slide, please. I want to illustrate that on one particular use case. Obviously, everybody talks about the things that they are coming from, that they know. So I'm presenting a large-scale user facility. In the photon and neutron community, we have large facilities such as synchrotron light sources and neutron sources that are, say, made available to the scientific community. And that means users from all over the world may submit proposals to access these instruments to get experiment time. And one important note for the photon and neutron facilities is that they represent a class of experimental techniques, but not a particular scientific domain. And that means we have users from all scientific domains in our facilities. Next slide, please. And what that means is that we also have all kinds of samples. We have lots of different stuff. We have single crystals, crystal powders, functional materials, so very simple stuff. We have more complex stuff like solar cells, batteries. We have macromolecular crystals like proteins. But we also have archaeological artifacts, fossils, artwork, painting, even living plants, and all sorts of things. In general, you can say every single object that may be subject to a scientific investigation and that is small enough to fit on a truck to be moved to our facility may eventually pop up as a sample in our facility. And that means it is very challenging to have one description scheme for all these samples because there are so many different sorts of things that you will not be able to formulate a metadata standard to describe that. So we need a different approach. Next slide. And obviously there are vocabularies for sample description around. So there is lots of scientific domains have their vocabularies to describe their samples. But these descriptions are always specific to one particular sample type. And in order to use a particular metadata schema, you would first need whether this sample that you have at hand is whether this schema is applicable to that particular sample. In other words, we would not first need to classify the sample types in order to know which metadata schema is useful to describe them. And I put that problem in the context of our facilities, but I believe it is a general problem that we always have, say, domain-specific vocabularies, but we need something on top. We need some entry point to go to have some specific type of a sample in order to know which, say, domain-specific vocabulary can be used. And of course, this overarching vocabulary is not meant to replace the existing domain vocabularies. It is a way to point to the correct one. Next slide, please. So as a conclusion, I believe we need a vocabulary for the top-level classification of sample types. As far as I'm aware, I might be wrong. There doesn't seem to exist something like that. And it doesn't need to go into a deep sample description. It may be very shallow. It's just saying, okay, this is a fossil, this is a battery, and that's it. But so it can be very shallow, but it needs to be very broad because it needs to be applicable to everything. And as I said, it's not about replacing domain vocabularies, it's about connecting them. So that was my short introduction to the topic that I see. And we scheduled a small discussion block right now in order to whether we agree on the distinction between sample description versus sample classification, because that is an important point. And I would like to ask the audience if there are, say, opinions on that, if there are remarks on that, or what do you think about that? Any?
Well, I think the sample classification should be one property for the sample description.
Yeah, sure. Any other comment? Is there? I don't have an overview about the online audience. If I don't know whether there's. Is there somebody raising their hand from online? Stephen?
Yeah.
Yeah. Want to comment?
Well, yeah, I mean, I think this is an important problem, and in the short presentation I'll give in a little bit, I think what we found in this iSamples project I've been working on, trying to develop such a cross-domain sample classification system, is that it makes, to get something workable, we ended up refactoring sample type into 3 different aspects, facets, whatever you want to, dimensions of material type, object type, and sampled feature. And I think that gives you a more workable system where you can have manageable vocabularies with 10 or 20 high-level classes in each one of those that can get you started. That was the approach we took, because there are so many different ways of classifying material objects that, it just kind of depends on what your perspective is, what you're interested in. And so if you break that apart, if you try to put them all in one vocabulary, you end up with this geometric explosion of potential concepts that you need.
Okay. Any other comment on that? If there's no further discussion of that particular, say, issue, then we can go into the presentations of that we scheduled. So the next one online would be Kirsten. And you can pass to the next presentation.
Number 2. Oh, first, the other one is number 1, it's number 2. Thanks all for coming. Okay, until it's coming, I'm Kirsten Elger. I'm affiliated with the German Research Center for Geosciences, GFZ in Potsdam, where my main job is to run a data repository, but I'm also vice president of the International Generic Sample Number. And I would like to just show that the IGSN is a community standard, one of them that Rolf described, that there are communities who have them, and we have a long tradition. So I just wanted to tell you how we are doing this, because this could be definitely included in any activity here. Oh my goodness. Okay, so I changed the title. Can you instead of saying samples are everywhere, I would like to to introduce to IGSN as an example for a community standard. Next slide, please. Well, I have my own picture for samples. We have many samples, and these samples are used to make any age determination of rocks. The timing and the place of the Cretaceous tertiary boundary has been also determined by samples, which is, everyone knows, where the extinction of the dinosaurs took place. So many disciplines are collecting samples, analyzing samples. To the lower left, so you see my son standing in a lab, and these are essential parts. Can you move on? And I have animations. So either I take maybe it's easier if I take it. Oops. Yeah. Okay. Anyway, I can stand here. Okay. No, hang on. How can I go back? Okay. So why samples? I'm standing here. It's not very fortunate. Just to illustrate what happens. So the classical workflow is that a geologist, for example, is collecting a sample. Then there's data being measured. Of course, the data is published in the data publication today. And then you further analyze it either with or without code. But then you have papers, which are your main scientific output, I would say. All these parts are, of course, assigned with DOIs and can be digitally connected through the metadata. And for samples, the IGSN, the International Generic Sample Number, represents such a digital object that it's also a persistent identifier that can be part of this and should be part of this digital curation workflow. So IGSN stands for International Generic Sample Number. It's governed by an international membership organization, IGSN-EV, since 2012. And we are speaking about more than 12 million samples. So it's not just a beginning project, but it's really developed. We have specific things. It is actually a globally unique and resolvable persistent identifier for physical samples and specimen. And since 2016, we have been acknowledged to be, or we have been included in the data site metadata as related identifier type. And this is actually the first PID for physical objects that has achieved that. So we can now be fully cited in data site metadata, and of course, ideally also in journals. So what does it mean? You have this IGSN, which is usually represented as a QR code on the sample, and then you can make these connections. So you can include, of course, the IGSN number in the table to the upper left, the blue fonts, and you can cite it in a data publication and in the paper. And as such, you really bring the sample to the digital data curation world. Benefits are, of course, to unambiguously cite and track physical samples. We have the normal use case that samples are frequently renamed when they move through laboratories, and using IGSN consistently and always assigning a new IGSN as a child of the previous one may allow to really track the results and the samples through the labs, and also to make connections in papers published on the same samples, which are often published with very different names. And it is possible, theoretically, we have not yet done it, to build a federated global sample catalog. And this is then the relation to the previous presentation. What happens when we could go out of the geosciences? So this is just, to the right, you just see one example of an IGSN landing page, which is the online sample description. And as such, IGSNs have a link. You put it and you come to the sample description. You can even remove any content of some content of your paper to make it more short and more better readable, because you can make all these sample descriptions on the IGSN landing pages. Next one, please. No, the other one. If you just give me that. Okay. We have agreed within IGSNEV on a modular metadata schema that is meant to be very flexible. So we started, because we used handle identifiers for many years, we had a very small portion of properties as mandatory fields for everyone. Then we had a descriptive metadata that was supposed to, or that serves as basic data discovery. And the aim was always to identify these as common kernel for all IGSNs, which would then be also included in any catalog beyond one repository. And then this was very important to have the possibility to add these metadata with very discipline-specific, sample type-specific, domain-specific metadata properties according to the specific repository that is actually providing these IGSNs. And this sample, oh, that's wonderful. So this sample type vocabulary, I would definitely see here in the descriptive metadata. If you look today, you won't find the registration metadata anymore, because in 2021, there was a strategic partnership between IGSNEV and DataCite, which mainly had the effect that IGSNs today are registered through DataCite services since 2023. So they're called IGSN-ID, they are technical DOIs, and they should be published through dedicated IGSN repositories within the DataCite system, and with a separate prefix to allow for easier analysis to bring everything together. This also means, and this is a challenge for IGSNEV, that previously we have been the central governing organization. Now every DataCite member can do his or her DOIs on IGSNs, and then the question is how closely are they following the metadata schema, and how can we keep somehow the samples together. We did a name change from geo to generic, because whenever we introduced to IGSN, we had many neighboring disciplines who said, oh, that's an interesting concept, but we are not geo, we are life sciences, we are photon and neutron sciences, we are archaeology, we are not strictly geo. So we had many discussions in the steering groups, and then we decided to definitely keep the acronym IGSN, but change the geo to generic to be really more open and to make it visible in our name. So at the moment, what we see is that there are current activities to explore IGSN minting, for example, as the IGSN Archaeology Community of Practice. IGSN is a perfect example for all these millions of artifacts of archaeology. And especially the hierarchical system that we have developed can be used to make sample, subsample, and digitally connect everything. Material sciences, Rolf showed his use case on the synchrotron, where all kinds of samples, may they be natural or synthetic or whatever, we can even put it to museums, to paintings, everything that is actually physical objects. But this, of course, means we have more community metadata standards, or not even any, more diversity, more challenges to bring everything together. And so I think, speaking with Rolf, and we've been preparing this more or less together, a top-level controlled vocabulary defining a generic sample type would be an important tool to connect and to bridge these different community metadata standards. That's what I wanted to say. Thanks.
Many thanks, Kirsten. The next presentation in a row would be from Stephen Richards. He is online and he drives his slides themselves. So if you stop sharing, then Stephen can do. Stephen, are you able to share?
Should be. Are you, let's see. Oops, there we go. Are you seeing my screen?
We see your slides.
Okay, excellent. So hi, my name's Steve Richard, and I've been working with a project that we call iSamples, based here in the United States. And the objective of this, well, of the iSamples project is actually to develop the kind of cross-domain sample registration aggregator that Rolf was just talking about. I'll be focused on how we try to categorize samples across these different domains. So we're dealing with samples for earth science, environmental science, archaeology, genomics, and biology from a number of different participating organizations. And the idea of the sample categorization that we're trying to do is we want to provide a high-level set of facets to assist. First, mostly where it turns out, I think, to be useful is in terms of narrowing search results. So you're interested in samples of a particular type, you know, archaeology artifacts, tissue samples, rocks, sediment samples, water samples, different kinds of things depending on the sort of science you're doing. So the idea of the application for these vocabularies is in developing these the facets. So the approach we've used is to look at the corpus we have, the existing sample descriptions in these different systems we're working with. So Open Context is a large aggregator of archaeology samples and descriptions of various archaeology projects. Geome develops, it works with a lot of genomic samples of various sorts. Cesar is the system for earth science sample registration, one of the precursors for IGSN, dealing largely with earth science samples, but actually includes a wide variety of samples of different types. And then we've been working with the collections at the Smithsonian, which of course have a very wide scope, but mostly to begin with, we've been looking at samples related to the biology collections there. So taking a bottom-up approach and looking at the actual sample descriptions that these various systems have in their databases, it became pretty clear to me, at least, and I think to the group, you know, we agreed that there was no way to develop a workable classification system across all these domains that with just a single vocabulary. It becomes ridiculously large, or if you keep it small, it's not very useful. And so what we've done is factored the classification into these different facets. So there's a material type. What is the sample composed of? The object type, what kind of thing is it? What's the object that you actually see in the drawer in the collection or something? And then what was the intention of the sample? What was it supposed to represent? What's the sampled feature? So these are different aspects of thinking about sample classification. And so on each one of these facets, then we looked at, well, what's actually in the data we've got in the sample descriptions that are there. And so here's, you know, some examples in open context data. They have an item type. And these are the counts for the different occurrences of these different kinds of item types. And the question is, well, how do these item types map into these sample classification facets we were thinking of? In the Cesar data, for instance, there's a variety of different ways of talking about where the sample was collected. So related to what's the sampled feature. So again, looking at with a bottom-up approach, with a unique values query against what's in the data, what are the different things that are actually there? And using that as the basis for developing a system, some vocabularies at a high enough level to account for all of these things without drilling into too much detail. So the important aspect of this system, we have these high-level vocabularies, but they need to be extensible. Obviously, as both Rolf and Kristen were pointing out, I mean, for domain-specific functions, these very general high-level vocabularies are not particularly useful. So they have to be extensible in some fashion. We've implemented the vocabularies using SCOS, which is an RDF vocabulary for describing, it was mostly thesaurus-based, and it has fairly simple relationships, but importantly, it has the ability to have labels for concepts, definitions, other kinds of labels if you want to include different languages or words used in different domains. You can point to a source, and you can have relationships between concepts in a very semantically loose kind of way. Broader, narrower are the kind of the important ones that we've been using. So the extensions then, the idea is that when an extension vocabulary is created, it's rooted in one of these terms from the high-level vocabulary, so that any term in an extension vocabulary can be traced back using, fairly simple SPARQL queries to find how is this related to the high-level vocabularies, which provides a path then for data integration across domains if you want to do that. And then I mentioned the metadata categories have labels and identifiers. And then in the metadata scheme that we've developed for iSamples to account for this, and I won't really be talking about the metadata scheme, but these category properties have a label and an identifier, URI, that allows for linked data approaches to doing the data integration. So quickly, just flashing on what's in these vocabularies at this point. We tried to keep them to on the order of 20 terms. So in the material type, this is what we have at the high level. I won't run through them all, but the whole idea is, okay, what's the substance? What is the sample? What's the actual kind of material that the sample is composed of? And then specimen type. And a lot of times this is a fairly tricky concept for a lot of people to grasp, the idea of what kind of object is it, as opposed to what is that object composed of. So there's some pictures here of some of the different kinds of objects we deal with. There's artifacts, there's pieces of rock, there's processed pieces of rocks in thin sections, there's liquids in containers, there's biological samples that might be all of some organism or a part of some organism, something like that. So that's the idea, is to categorize those things at this level. So that's the specimen type or material object type, which is what the terminology we're using now, following the Tadwig discussions about what do we call these things, material samples. And then the sample feature vocabulary. And again, what's the sample supposed to represent? And this is probably this is one of the trickier ones, because again, there's so many different ways of thinking about why this sample was collected. What's the sample about? And so the things that are here largely focus on kind of Earth environments. There's a little bit about anthropogenic, but obviously all these things, again, in order to keep them high, they're extremely general. So the basic divisions are things related to people, environments, anthropogenic. There's biological things. There's things related to the Earth environment. And then there's extraterrestrial stuff, because meteorites are in scope, and as we get more and more samples from other planets and the extraterrestrial environment, again, that probably needs extension. So how does the extension system work then, the idea? So here we have the material vocabulary for iSamples, the base. And there's a natural solid material, and the kind of a rock is a kind of natural solid material. But if we jump then in the iSamples, we have a few extension vocabularies defined, one of which is for the Earth materials. And so in that vocabulary, rock is subdivided. There's a bunch of different subclasses under rock. So this has the same, this concept here is the same as the concept from the high-level vocabulary. It has these subclasses. And then to account for all the variety of things that we have in Cesar, then there's a Cesar extension which adds more subdivisions. So for instance, with metamorphic rock, then we have lots of different kinds of metamorphic rocks that people might be interested in. So in the data, something might be specified as one of these more granular classes, but it's easy to trace it back to how that corresponds with the high-level classes here if you want to try to do some kind of cross-domain integration. So in the SCOS encoding for these things, we have, there's namespaces here. I'm assuming people are more or less familiar with how this works. So RKSD is the iSamples extension vocabulary, and andesite is one of the concepts in there. And the idea is that for any of these concepts, then it has links to broader concepts. And in many of these systems, things don't have a single parent type. So you could view an andesite as a fine-grained igneous rock, a volcanic rock, or an igneous composition igneous, has different parents. And the other thing that we do in the vocabularies where we can is we have mapping to other vocabularies. So here we use a SCOS close match, which is one of the matching predicates that we have in SCOS, to relate the concept, the andesite concept in this vocabulary to the andesite concept in another vocabulary. This is a GSO, this is an ontology that was developed for the Link 3D project in Australia, but there's various other mappings that could also be included. So this is how the SCOS encoding works. So to really make this work in practice, then you sort of need to have a triple store that allows you to trace these relationships up and down these various hierarchies. And in a user interface, it gets tricky because then you say, if somebody says, I'm interested in these kind of samples, then that might dictate a whole set of extension vocabularies that would be related to that kind of sample that you might want to provide for your users. But all those things need to be implemented on the user interface, and they're not built into the classification scheme inherently. So with that, this work has been going on these GitHubs. There's an iSamples GitHub, iSamples.org, where all this is contained. If you we have this metadata scheme we've developed that we've used for building an aggregator, harvesting metadata for samples from the different partner systems into a single aggregator. And that's documented here. And then the vocabularies are implemented. There's turtle files for the SCOS and also HTML web pages for looking at them. And we're working on a publication that's, well, it's been submitted and it's online in the Semantic Web Journal, but we're working on a revision to get it actually formally accepted. And so leave it with that. If there's any questions, we can talk later. Thanks.
Yeah, very many thanks, Stephen. I would say that already looks pretty much into the direction that we are looking for. So we will definitely need to look closer to what you did, and to that for sure. But we have a third contribution from Rowan Brownlee. He was not able to join the conference, so he sent us a pre-recorded contribution, and I asked my fellow colleague to. Did you share the sound? Sorry for the sound issues. We will restart the recording.
opportunity to contribute to this BoF. Certainly a session with a worthwhile aim, exploring the question of adopting a shared upper level classification. No surprise to those gathered that development and adoption of a shared standard depends upon consensus. In this presentation, I'll describe ways in which a vocabulary service, such as the one provided by ARDC, may support development of consensus, support agreement on adoption of shared vocabularies. But first, I'm speaking from Canberra in the Australian Capital Territory, and I wish to acknowledge the Ngunnawal people as traditional custodians of the land and recognise any other people or families with connection to the lands of the ACT and the region. And a brief background note. What is the Australian Research Data Commons and what does it do? The ARDC runs programs and facilitates partnerships. It seeks to ensure that Australian researchers are internationally competitive by having access to high-quality national data assets, platforms, infrastructure, policies, people, and training to transform the lives of the community. On to the substance of the presentation. These are the areas that I'll touch upon. ARDC provides a vocabulary service, Research Vocabularies Australia. There are a number of ways in which RVA has sought to support consensus development, support agreement on adoption of shared vocabularies. At its core, RVA provides services for managing and accessing vocabularies, and RVA encourages standards adoption by publishing community guidance on selecting vocabularies for reuse, by supporting the voices of domain informatics leaders, by promoting the value of shared standards, by describing pathways to locating community data standards, and by supporting a discussion forum. In brief, these are the service components of RVA. ARDC provides software for editing vocabularies, a registry for hosting vocabularies, and a discovery portal for enabling access by people and by software. APIs and widgets for use of hosted resources by other services. A subscription service. One may subscribe to a vocabulary or a publisher to receive updates on new versions of a vocabulary or new vocabularies that have been published. RVA welcomes hosting of international vocabularies of interest to Australian research. If you may be interested in using the service, you're most welcome to get in touch. RVA is typically used by projects and agencies that want to improve the informatics landscape. Projects and agencies that have standing, even authority in their domain. Initiatives that are seeking to foster consensus around adoption of shared standards. Consensus on defining, selecting, and applying semantic resources such as controlled vocabularies and classifications. You may recognise agencies and projects on this slide. These are users of RVA services, and they are also creators or publishers of vocabularies that are hosted by RVA. An example of an initiative aimed at encouraging adoption of standard vocabularies. RVA users reported challenges in selecting vocabularies, particularly in cases where there may be more than one vocabulary to choose from. ARDC worked with domain informatics people to explore an approach to providing guidance on vocabulary selection. ARDC collaborated with members of the Australian National Earth and Environmental Sciences Facilities Forum to develop a guide to vocabulary selection. A guide to vocabulary is used by members of the Australian National Earth and Environmental Sciences Facilities Forum. These are forum members who contributed to the guide, some of whom you may recognise. IMOS is a member of the forum. IMOS, the Integrated Marine Observing System. Within the guide, IMOS, along with the other forum members, has an information page, a page about IMOS, what it does, and its standing within the data and informatics community. This is IMOS, and these are the vocabularies that it uses. One of these vocabularies used by IMOS is the AODN instrument vocabulary. If I visit the landing page for the AODN instrument vocabulary, I can see who uses the vocabulary. In this case, IMOS and the Federal Environment Department. I can also see the purposes for which the vocabulary is used by those agencies. In gathering this information, the guide seeks to help a user answer questions like, I have a purpose that would suit a vocabulary. I don't know which vocabulary to select. Can I see some examples of vocabulary use that may match my purpose? Another example of an initiative aimed at encouraging the adoption of standard vocabularies. RDA promotes messages about the value of vocabularies, tries to push clear, simple messages. For example, that vocabularies express agreement on meaning. Agreement on meaning enables communication, and the meaning of research data can be communicated through the use of shared vocabularies. And that agreement is essential. Consensus underpins adoption of shared vocabularies. It's one thing for ARDC to promote the value of vocabularies. That's all well and good. But even better for the argument to be made by researchers within a domain, by informatics people who have standing, authority within their community. ARDC publishes stories about the value of vocabularies using the words of domain informatics leaders. These are published as impact case studies. The value of good data management practices, including the application of shared vocabularies. This example in marine science discusses the work of IMOS. And there's more that could be done here to develop the status and authority of informatics leaders, to help position and promote them as examples to others, and in doing so, to grow the community, to foster development of informatics capabilities. Another example of an activity aimed at encouraging adoption of shared vocabularies. People face challenges in finding community-endorsed standards. ARDC publishes a guide to some common steps to help searching, like look at existing infrastructure projects. Do they include working groups focusing on domain data standards? Scan the professional associations. They may have oversight of standards development activities. And try some domain-agnostic directories of data standards. And ARDC supports a discussion forum concerning vocabularies, an Australian group, though anyone is welcome to join, and we include presentations from international members. And so in summary, ARDC provides a vocabulary service that's underpinned by collaboration with domain agencies and projects to work with informatics people in the pursuit of consensus, to assist domains to guide their constituents on vocabulary selection, to promote discussion, to promote and develop the voices of domain informatics leaders. Finally, a note that international users of RDA are welcome. Get in touch if you wish to discuss.
cannot hear us, but we thank him anyway. So that was, say, the content that we prepared beforehand. Now it's on you, on all of us, to say, what are our conclusions? What do we think about all of that? Are there?
Well, I think especially what Steve showed us makes it clear that we, instead of starting a completely new initiative, I would prefer to closely collaborate with Steve and Kerstin and everyone who's around iSamples, and just make sure that additional specific sample types are included in that, because I'm a big fan of these SCOS vocabs, and Steve is the master of that.
Hello.
Stephen, is that you? Please speak up.
Yeah. I was just going to say that the vocabularies we've developed and been using in iSamples are actually posted on the Australian Research Vocabulary site that Rowan was talking about. I put a link in the chat if anyone wants to have a look at what that looks like. I think it's been very useful and provides a good way for people to have a look at it, and we'd certainly love to get feedback and figure out how to make them work well.
Yeah, I mean, I'd like to add to that. I learned a lot from your contribution, Stephen, and definitely what you have doing is exactly in the direction that we had in mind. So we will definitely build on your work.
Thanks. This is David Elbert from Johns Hopkins and from the material science domain. And I think that as BoF, we're already birds of a feather. And I think that a decision might need to be made between how we think of collaborating with different projects and trying to bring them together versus having an umbrella, which is the IGSN, which gives us the PID, and being able to have other projects plug into that, and what needs to be created so that we can link other projects. Because I don't think we should shut down other projects or consume other projects, and which no one wants to shut down a project, but they're also really politically important because they have funding, they have ties in communities that are beyond this. Things show very strongly about the geologic roots still compared to materials science. I come from a geology background. A sample is something one goes and gets. And it was already created. In the materials world, we're very interested in how the material was created. We have information and we controlled that. Whereas in geology, we're very interested in how the sample was created, but that's an interpretation that comes from the data. So they really come at it in very different directions. So I think knowing what we need and then deciding if there are tools that IGSN needs to create, so maybe a good description, so a community like iSample or something in materials world would know, what do I need to have? I need to have a vocabulary that looks like this. What do I need? And then what tools do I need to say, here I go, and I say, please IGSN, accept me, and it happens. Something like that would be useful.
I think there is an opportunity within IGSN to do what you described. It's just not been widely advertised yet, if you will. So IGSN provider, the repository that's providing IGSNs can develop their own metadata schemas. But then when the registration goes through DOI, it has a specific, also this discussion within data into the metadata profiles associated with IGSNs. So there's an opportunity there, again, to have some input into expanding the data site registration much more globally available. But the registering organizations themselves manage the repositories. So they have a lot of control over how rich the metadata is for the people. So USGS is taking an approach where we're requiring much IG will be on the landing pages, registry, so all of that information.
Adding to Lindsay, thanks for this up. This is the purpose of IGSN metadata and the purpose of DataCite metadata are not equal. When we started, we had, I think, with all these merged, this involved not only changing our registration services at the agents, and especially Cesar and iSamples were those who really had they had most of these. I think they had 8 million, or I don't know how many. So it's also, we had a very short time to map it, and there was a dedicated metadata working group that resulted in the IGSN DataCite recommendations that were focused on the mandatory fields only, just to move this registration. But I think that the DataCite metadata schema has options to include controlled vocabularies with URL and URI and all these SCOS things. They can be included in the metadata, and we will definitely work on more. And it's interesting that you say IGSN could be the technical implementation. That would make us, of course, very happy. But you also have to, I don't know if all of you are aware of this, but what Steve presented is IGSN at the basis. So they are really the major player in the IGSN world with Kerstin and Steve. So yeah, and I think we can use this BoF because RDA is not domain specific. So we can use it to bring the ideas to a more interdisciplinary content and to really bring in the groups who are possibly representing or using different samples to either by explaining what Steve said, but I liked your term of additional or expanding vocabs. So this would be, this would be a great idea, I think, but we could benefit of this RDA community to really bring everyone together.
I like to make 2 additions to the discussion. First of all, I agree completely what you said, but I want to remind that we are not about, say, a better metadata schema for describing the samples. We are about, so what we have in mind, that sample type would be just one single attribute in all of these sample descriptions. And that single attribute should then be standardized over all the metadata standards that we have around. And the second thing is, what would be the role of RDA? So I mean, what you presented with iSample, at least at first glance, it already looks like you already solved our problem. I don't know. I still believe that we would need to look much closer to that and to see whether it really matches all our use cases. But even let us just as a potential assume that iSample is already what we want, might be. Then still RDA has a role on endorsing that as a recommendation so that everybody uses it. And maybe we contribute to iSamples to enhance that for other use cases that are not well represented at the moment. Maybe we build on that something new. I don't know. It is open.
Good.
Stephen.
I guess to me, one way forward and the way we've kind of been doing this is to bring in, so we were looking that we had the example of the material science samples. And so it'd be really interesting to see if they have a database with a bunch of their sample descriptions that somebody might have compiled that we could look at and see, okay, can we map these into these vocabularies without having to do any ridiculous shoehorning. And that's, what I've seen is, generally when we start doing this kind of thing, you find gaps, there are definitely going to be gaps. And so the trick is to find those gaps. And to me, I think the most useful way to do that is this bottom-up approach of actually, right now we've got enough samples in enough different places and enough different databases that we can actually work from existing data rather than, when I started doing this a while back, it was mostly kind of top down. You kind of thought about the domain and said, okay, these are the things, but I think it turns out to be more useful to start with, okay, what have people actually done in systems that are working and people are using, and use that to determine what do we need in this vocabulary. So it'd be great to get some more sample description databases to look at.
Any more statements?
I mean, my assumption is that many samples are going to have many sample types associated with them, right? So it's not, you're not going to make one decision about a sample type, but it's likely to be many for any particular sample.
I don't know. I guess that depends on the vocabulary that we end up with. But I don't know.
I'd have to say it in practice. That's true. That's come out true. Even dividing things into these facets, that you can run into situations where you want to say, well, it's actually this and that. It's this kind of object, but it's also this other thing that somebody might think of. So yeah, it does need to be multi-valued, but part of that's in how you build the metadata scheme. So right now, the metadata scheme allows you to have as many of these category assignments as you want in the iSamples metadata scheme. And in DataCite, those could be done as keywords with the labels and URIs, same kind of pattern.
Are there more, say, contributions to the discussion, maybe from other online people? Or from the room?
Yeah, I just was thinking on Lindsay's comment, and I'm with the National Ecological Observatory Network in the US. And for example, we have soil samples that we collect and we do subsampling of those. So some goes to do soil texture analysis, some goes for biogeochemistry analysis, some is frozen for microbial genomic studies. So yeah, there's, once you start breaking those samples down into those components, it gets a little tricky.
Yep. Okay. More opinions, contributions? Was that it? No, apparently not. Kirsten, what is the situation now?
The situation, I think we should. I would like to ask both the online audience and the on-site audience whether, because usually when we have a BoF, we can decide on, shall we proceed with either a working group within, for example, the physical samples interest group that is also existing and where the co-chairs are here online, or whether, that's for me the only thing that makes sense, but are we already at a state where we can actually form a formal working group? Because once we are acknowledged as a working group, we have 1.5 years time to present results, or whether we like to first form a subgroup in the physical samples interest group, where we try to ask for specific slots to further address it. There would be the two options, or we can just be separate, but this is not advisable for me, I think.
I mean, my interest would be that we end up at some point in time with an RDA recommendation on vocabularies for sample classification. And the standard way to go there would be a working group having that as a goal. And of course, such a working group would, of course, collaborate with a physical sample interest group. I mean,
no, you need the mic, otherwise it's not fine.
okay. So I would like to have an RDA recommendation on a vocabulary for the classification of sample types. May that RDA recommendation that we need to improve or complete eye samples, whatever. That would be the work of that working group to do. It's not to try it now. But what we need to decide today, ideally, is whether we want to go that road.
So I agree, and I think that makes a working group. So we don't have 18 months to get a vocabulary recommendation, and then we need another 18 months to be using the vocabulary recommendation. I'm pushy, and we've already been waiting, and more of us are making decisions and moving ahead and making ridiculous vocabulary choices. Like for us, you have a piece of something. Is that a sample or a specimen? And then when you look at little pieces of it, are those the sample of the specimen or the specimens of the sample? People already make those decisions. They're easy words to use, and later unwinding them will be a pain in the neck. Yeah, we. PIs I have to work with make those decisions and sit back in their chair, and it's done.
I mean, my take on that is we definitely will not stop the word from moving. And I mean, if we are able to come up within 18 months with a recommendation, that would be a great job. I'm not sure that we can be quicker than that. But as sooner as we get to that, the better.
I don't remember exactly how the RDA working group process works, but could we make a recommendation as part of the samples IG? And so both be within it, but do the work within that structure as well, so that it comes out of the samples working group, or we have to be completely separate?
I'm not so sure whether there is a big difference between both approaches. I mean,
I think there is a difference, because normally an interest group, and the physical samples is not a working group, it's an interest group. It's like combining everyone around physical objects. And for me, having a separate, dedicated working group, not related to that one, would be not a good option, I think. We should have a home in the physical samples, because this is already, that's the community of practice, and we can usually, one interest group has one or several working groups, so this would be for me the most logical part. But I would like to hear especially the opinion of Kerstin, who's online, and Steve.
Kristen had to leave, unfortunately. But I like the idea of a working group as well. And if that's I mean, again, I'm not up to speed on all the RDA processes, but I don't think a interest group makes recommendations, right? Don't you need to be a working group to make a recommendation? And so if we could create a working group as part of the interest group, that seems like, I agree, it would make the most sense. And the process would be, we would have to develop some kind of case statement or something like that, and then get that approved. But as far as the timeline, I mean, we have to produce a product in a year and a half, but there's no reason we couldn't produce something quicker along the lines of what was pointed out about we're all impatient to get moving along.
Of course, a working group is not forced to use up all its 18 months if it's able to produce something quicker. No, but let me explain why I believe these two approaches are not so different. First of all, interest groups can produce RDA outputs. There's nothing to forbid them to do that. Secondly, I don't see that separation. So if we form a new working group, I don't see it being separated from the physical objects interest group. There's a huge overlap of people that would be in both of them. And of course, we speak to each other. And of course, we would say everybody in the working group might be interested also to visit the meetings of the physical sample interest group. I mean, there's only a nuance of difference in that we collect a subset of people who are focused on that particular task. But I would believe that such a working group would be part, in some sense, of the physical sample interest group.
So I think we all agree on that. Because you just said exactly what I suggested, just with different words. So we all agree we would be part of the interest group on physical samples, and for getting a focus on these vocabularies, apply for an independent or like for a related working group as part of the interest group.
Yeah, so we are 20 minutes early, but 15, but already having.
So I don't think this goes in this working group, but I'm going to seed the idea that the name of this BoF was sample classification, and everyone here is talking about physical samples, and in my world, virtual samples are very important, right? Because we do computational modeling, so people create samples, and I think that ultimately they can take advantage of this, and we can have a similar classification for virtual samples. I wouldn't mind rolling it into the same thing, but there'll be things that will be alien to many people here. For instance, we create a virtual sample that has a specified microstructure in it and preferred orientation. In a geologic sample, you say it's a myelinite, but you haven't actually done EBSD on it or anything when you name the sample, so you don't classify the specificity of the microstructure, but when you make it with that microstructure, right? So I would like to see virtual samples handled the same way as physical samples. That's the way we do it in all my projects. But there will be extra things. So if I can just plant the seed, that virtual samples should be able to come here too at some point.
I would suggest that this is part of the work that the working group has to do to consider how to integrate these virtual samples. I could add another remark that additionally to the RDA activities that we're discussing now, we do have a, say, uncertain option of getting some funding. We say, have the idea to submit a proposal for the Oscars cascading call, and that might provide us with, say, dedicated people working on that. But of course, that again would then be integrated into the work of RDA. And this is very uncertain whether this funding would have a chance to succeed.
So
Yeah,
if I could,
just
I don't what the process would be, but it's, I guess, let's form a working group. What do we need to do? I mean, do we need a, like,
I think we need to make a suggestion to the next plenary. And when we are approved, that we need to have chairs and a dedicated description. And of course, we have to bring this topic into the physical samples interest group. That is, I don't know if they're meeting this time, but that's the steps. I think we could be ready for next plenary, which is virtual. We should be, if we want to go. Yeah.
so as far as I'm aware, the process is essentially, of course, we need to find a group of people who want to drive that forward. Then we would need to write up a case statement that we would then need to submit to RDA for review, and then we get approved or not. Most of the cases they get approved, I believe, if it's, say, not nonsense what we write up. And then, yeah, it's a question whether we are, I mean, there is a chance to have that case statement ready by the next virtual plenary. I don't think we will have the approval by the next virtual plenary, but that is not so important thing, I guess. So yeah, we shared the link to the collaborative notes. So it would be very useful if everybody who is interested in driving that forward, say, indicates that in the collaborative notes so that we know whom to contact in order to form a, say, a group of people who prepare that case statement. Okay, and if we don't have anything more to say, nothing.
We are first in line for
Thanks. Hi. Not so much a question, just to say that RDA Tiger has been in the room. So we just launched a call for cascading grants for RDA Tiger, and there is our ongoing continuously open call for support services. So now my colleague as well from RDA Europe is here. If you have any questions that we can answer now, we're happy to. Otherwise, we have an exhibition booth just outside the main plenary room, and we would be happy to see how we can help the group forward.
Yeah, indeed, that would be my interest to learn what would be the next step. So or first of all, what you have to offer for an emerging working group, and what would be the next step in order to get that. I will approach you. Okay, then I thank everybody in the room and in the virtual audience, and thank you very much, and I close that session.
all righty, thanks.
Steve, are you at AGU?
No, I'm in Tucson. So
No, but are you attending
oh
AGU?
no, I will not. I will
No.
not. Will
so
you?
we communicate. That would be. I'm coming. That's cool.
Okay. Well, I can work on drafting up at least a framework, a start for a case statement. I'll pass it around to everybody.
So you may stop the recording.